In addition to supporting standard engineering calculations, now EngineeringPaper.xyz supports matrices. So let's take a look at how to create a matrix. So we go to the matrix tab of this keyboard. We can just hit the size of matrix we want. So if you want a 2 by 2, and we just type in what we want for each of the entries in the matrix and hit tab to go to the next location. First, I'm going to do matrix multiplication, which is the @ symbol on the keyboard, or it's the X on the virtual keyboard. We have the standard scalar multiplication with a star, or the @ symbol, or X here provides the matrix multiplication. It's important if you're multiplying two matrices to use the matrix multiplication symbol. The keyboard shortcut for creating a vector and matrix is to use square brackets and a number of rows, number of columns. So I want a 2 by 1. Hit the enter key, and that creates the quickest way to create a vector or matrix. And so if I do fill that in, hit equals, it'll do that matrix multiplication for me. Of course, it's going to support units as well when I create a vector. So let's create a 2 by 1 vector. Let's do 3 meters in the first entry. The second row, let's do 4. Right? So it'll keep track of the units, carry through the calculation, just like any other calculation in EngineeringPaper.xyz. I can, let's say I want to do the norm of this vector, highlight it, hit the vector norm here, and then I get the magnitude of the vector. And again, it keeps track of the units for that calculation. I can also define variables. So if I do A matrix multiplication times V equals, right now it doesn't know what the values are, so it's just showing me that result symbolically. But if I define A, and I'll do a 2 by 2, hit enter, A, B, C, D, fill that in. And if I do V equals, actually I can do it after the A here. I'll do a comma. V equals a 2 by 1 vector, S and T. And so it'll do that as well. So I can define variables. Here, if it's important that since the left and right I expect to be matrices, I use the matrix multiplication operator with the @ symbol. If I do the star and scalar multiplication, I'm going to get an incorrect result here. So it's important to keep track of, use the matrix multiplication X instead of the star whenever the left and right hand center matrices. If you have a scalar, I'll do 2 times. I'll use the star asterisk to get the scalar multiplication. To access entries of the matrix, I can use subscripting. So I have to do A, and I can hit the subscripting button here or the underscore key. So underscore the row. So let's say I want the second row, first column. That should be C. I get that right here. It's important to note that even for a vector, vectors and matrices are really the same thing. So for a vector, even though it only has one dimension, I do need to specify both row and column. So if I want the second row, first column of the vector, I'll need to use the 2 indices. And so if I want the first element, it'll be 1, comma 1 to get the first row there. And keep in mind that the rows and columns do start at indexing of 1. To do a dot product, I'll just hit enter here. I'll do the dot function, and I can do, let's see, we'll do 2 by 1 here. So as long as the dimensions of the matrices are consistent, and then comma the second vector, we'll do 3. We'll do a 2 by 1 here as well, 3 and 4. So as long as the vectors are compatible for the dot product, it'll calculate the dot product for you. I can also do a cross product, and that's done just with the matrix multiplication symbol. So for example, if I do, let's say our first vector, we'll do so dot products have to be a 3 by 1 or a 1 by 3. So if we do 1, 0, 0, and then matrix multiplication with the @ symbol, another 3 by 1 here will be 0, 1, 0, and that's going to be the cross product of those two vectors. If I want a matrix inverse, what I can do is do A superscript -1 with the caret symbol, or I can just use the inverse button on the virtual keyboard. A transpose, the keyboard shortcut for that is just the apostrophe symbol. So I type apostrophe, or if I hit the virtual keyboard, it'll give me the transpose of that matrix as well. You can check out some additional documentation on the example sheets. If you hit the left menu, go to matrices and vectors, and that's going to show you how to use. One thing you can do with matrices and vectors is use them in the solver for system equation solving. So if I use a system equation solve cell by clicking that button, I can type in a matrix expression and solve for an unknown variable or multiple unknown variables. So here it's doing the eigenvalue problem, or I can do just a normal linear set of linear equations. So A, B, C, D times my unknowns. I'll do a 2 by 1. So U1, U2 equals. So then I enter the variables I'm solving for, U1, comma U2, and it gives me a solution, which is basically just inverting that matrix. The system solver cell can handle both scalar equations, systems equations, and matrix systems equations, or a combination of both.